Hi, so we will be talking about our topic, which is my topic, study of modern machine learning techniques in automatic short answer grading. So, in this topic, basically, what we are going to see, right? That we are going to find modern machine learning techniques that can grade short answers, especially point-based answers. Like when you go for a biology exam, we it is asked what is the functions of heart. We state down the points of what is the functions for heart. So we are specifically looking at points, at answers which can be given in points. But we are also going to see other kind of answers which can summarize context, such as comprehensions and all. So this is our research question. We will be finding best machine learning techniques for independent answer-based systems. We are going to assess BERT. We are going to assess how traditional models work uh, versus BERT. Yeah, and that's our research question. Now let's talk about our data set. So our data set is Helvet Foundation. Our data set is Helvet Foundation. So Helvet Foundation short answer scoring. So it was a grade 10s. Uh, as you said, the so it was used for a Kaggle's competition. So it's a public data set, and we don't have to take any GDPR concerns in it. This is a public data set, and that data set looks like this. It's a TSV where the ID is given first. Means each question has an ID, which essay set it belongs to, what is the first score, then the second score. We have to only consider the first score, and then the essay set means the student has given what answer. So that's it. So we can train the models on these essay texts. So this is what the essay set is. These are the answers basically for each essay set. What the student has got and what marks they have got as per that. So we finished speaking about the data set. Now we'll talk about the methodology, how we went about researching in this project. So let's see. First, we started our research project. Then we found the what do you say data set which we require for the conducting the research. We we searched as many papers possible on the internet related to automatic short answer grading, specifically from 2010, not earlier than that, because the papers earlier than that were very basic. Then we research various libraries which can give the BERT implementation. Simple transformers library is a simple library given by Hugging Face, so we use that. Then, since I didn't had a GPU on my computer, we moved to Google Colab since it is giving a Tesla K80 GPU, uh, which is by NVIDIA. Then we implemented various simple transformers, uh, which were given in 2000. So papers from 2019, they were mostly classification models of bird, or either they were Q&LI, where you fit one sentence and the second sentence together, and you fit it through the model. And when you give the question, when you give the first and second sentence back, it will assess how much it is equivalent to the topic. So now, and other thing was language text representation, which gives like sentence embeddings and word embeddings. So that did not work as well. It was getting very high RMSE, so we didn't go ahead with them. Another small thing to mention in the dataset is that each question has been given only about 2000 responses, which is quite less. But BERT is already trained on huge corpuses, so we had to just fine tune it on our downstream NLP task. So finally, we found the BERT regression, which is BERT classification with the regression option. We tested it on the first, second, fifth, and sixth data sets. And then we found that, okay, instead of 100 epochs, 15 to 20 epochs is just giving us the fine amount of evaluation loss. So we went ahead with 15 epochs. So we tried traditional methods like bag of words, TF-IDF with SVM. So bag of words is very primitive. So we didn't use bag of words. We used directly TF-IDF. Uh, we replaced SVM with several other topics, with several other machine learning techniques like like uh, random forest regressor, naive bias, Gaussian naive bias regressor. But we found that the random forest regressor was the best, and we chose 100 trees in the random forest regressor. Uh, Now there was a predecessor of BERT called word embeddings, and the which use the cloud data set. So we use a cloud data set and we trained it, but it gave high RMC uh, compared to the BERT regression and TF-IDF plus random forest regressor. So we only compared the two. Uh, Then we even cleaned the dataset and tried BERT regressor and random forest and TF-IDF plus random forest regressor. Finally, we tried BERT regression and random forest regression with TF-IDF on all the essay sets. And there is where our research came to an end. We researched all. So why TF-IDF plus random forest? Because it give the best results compared to all the traditional methods. So we can say that KF IDF plus random forest regressor can be used as a model to benchmark for all the traditional methods. So that was our methodology. Now we'll go to the evaluation part. In the evaluation part, we can see the first data set. So let me show you how the picks are uh, are distributed. On the left top side, we can see the BERT with unclean data. Then below it, we can see the BERT on clean data. Then again on the right top side, we can see uh, the traditional methods with the unclean data and traditional methods with the clean data. So let's see the first data set. On the first data set, we can see that BERT without on unclean data gives the best accuracy with the least RMSE and more Pearson correlation. Similarly, after cleaning, the RMSE increases, means bird didn't do well after cleaning, and we can see the RMSE is high for TF-IDF. So this specific question, they had a passage, science passage, and they had to give the answers in their own words. So this is where bird shines out because it can understand the meanings of the phrases and the sentences, whereas traditional methods cannot. Moving on to the second data set, the story is same. The RMSEs are quite wide and differentiated. The other thing that these blue plots find is if the points are more more diagonal, means it has fit the curve much better because the predicted values are on the y-axis and the actual values, the test values are on the x-axis. So more they look diagonal, more the better. So the SSL2 birds still shine well. There's a separation between approximately 6 points. So these RMSE values are multiplied by 100. So we get a double digit figure. So it's not actually something 0 to 100. It's something which a human can read properly. Then we can see here bird in the third data set it didn't fare well because most of the words were same, but the meanings were different in each answer. So here the actual traditional data set worked better, whereas BERT did not work well in this. This is only one case where this has happened, and we can see that from the plots as well. Now we see of the fourth one. Fourth one, all, yeah, BERT again did well. with least RMSE. The Pearson correlation is not that great, but it's well. Then the fifth and sixth is which actually did good. Their Pearson correlation is good and they have a low RMSE because this is a point based answer. Fifth and sixth data set. Let's show you the sixth data set here as well. The BERT has done good, and you can see the Pearson correlation is better. Other data sets have the same type of inference. BERT gives lesser RMSE when it's unclean. As you can see, years 18 and years 20, and then the traditional models on the right side. You can again see that BERT in SSZ9 is better than the traditional models. So that was about our evaluation. Now let's move on to our inference. BERT can understand similarity. So we've seen that BERT can understand similarity and context between sentences, given the amount of corpuses it has been trained on. Uh, so BERT performs bad, as you can see in the third data set, and I gave you the reason already to it. There are many when we clean and process the data set, BERT actually gives a bad score because it's not used to getting just keywords. It wants to read the whole sentence, the meaning of the sentence. And we already spoke about the epochs, then the RMSE of the model. So uh, a, a, a model has been trained on one data set and a model has been trained on another data set. Their RMSE does not match. So that means if the RMSE of one model is say 18 and the RMSE of one model is 15, that does not mean that the second model's accuracy is more. It just means that they are two different data sets. The RMSE does not make sense for two different data sets. So that's it. And prior to these experiments, we compared random forest with SVR and non-gravity bias, which I have already told. And TF-IDF is a superior method for converting data sets into what you say trainable independent data sets. Convert sentences into features, and and speaking about QNLI, we didn't have a lot of data for training it in QNLI. Else, if we were having like a lakh, like 100,000 data points per question, then we could train the model on a QNLI, where one model it can be trained on each question. For example, for one model, we train all the 10 essay sets, and you have to just pass in the question and the answer, and it would give us how close uh, the answer is similar to the means the how correct the answer is. Yeah, so that's it. And for the conclusion, I would say that yeah, does perform well on point based answers, and as well as it performs well with what do you say it, sorry, DF-IDF plus random forest situation performs well with point-based answers, but can still be specialized in answers where different words are used, but the context is the same because it has huge amount of embeddings inside it due to the huge corpuses that have been trained on it. Thank you for looking at the presentation. If you have any queries, kindly connect with me uh, on my email, or in the you can ask me answers on my uh, on my research project. Thank you and have a nice day.